Okay, I thought I would just show you 19, 20, and what was the other one? 30 was the other one. Sorry. And give you the answers and how to find the answers. So when they are talking about find the domain and the range of a relation with a graph, the domain, they're talking about where your graph is on X. And for range, they're talking about where your graph, like the space it covers on Y. Okay. When you have an arrow like this, an arrow in both, not in both directions, but when you have an arrow and you see either a pattern or just movement in one direction, the arrow means continues this way forever. Okay. So I think that part is confusing. Continues, I would say in this way forever. So that's a confusing part for me. But basically it will keep going from this furthest. This will be the furthest it goes on the right. This will be the furthest it goes on the left, and it will just continue in that way forever. If you have a graph that's like this, that just means it goes up forever. Okay. But this one, because you can see that there's a pattern that keeps repeating, it's just going to keep repeating positively on the y-axis and negatively on the y-axis, but it's not suddenly going to start going like this. Okay. So that's what the graph is doing. And then domain means our X, range means our Y. So where domain, they're just asking what X values does the graph cover? Okay, when we look at the graph, what are the X values the graph is between? So determine the domain of the relation, select the correct choice below and fill in the answer box to complete your choice. The domain is the single value. Okay, if a domain is a single value, that means that if this is my X and this is my Y, so this is representing this. I'm just not very good at it. Okay, and then I'm going to make my actual line a different color. So if my domain was only a single value, remember domain is still X. So if my X was a single value, that means that the only place my graph can exist on the entire X-axis is right there. So maybe that's 4, right? So here X is 4. So my domain would be the single value 4. Okay, that is not the case here, right? There is more than one X value that if I was to just pick a point on my graph, if I pick this point, X is, let me see, -1, right? That point, for example, would be, sorry, I think -1, 9, right? Because -1 is our X, 9 is our Y. Down here, we would have another -1 for X, -5 for Y. So we know that the graph crosses at X equals 5, or sorry, I'm just totally making this confusing. We know that the graph crosses X at X equals -1, and then X equals -2, and every point in between X equals -1 and X equals -2, right? Because it's a line, so it's joined all those points together between -1 and -2. It also can go on to -3. It goes on to -4, and then the furthest the x value goes would be a -5. Let me see what this point would be. -5, +5, I think. Good. So our graph, this graph has a domain of 4 because the only place it ever is at x equals 4. Right? X equals 4 all the time, no matter if I pick this point, this point, this point. This is maybe 4, -1. Here's 4, -2, but my x will always be 4. So my domain is 4. Here, my x is -5, and then up here, my x will be -4, and then -3, and then -2, and then -1, right? So we don't say that that's a single value. We say it is an interval, okay? An interval means from your first term to your last term, okay? So we're saying that the domain, the x values of this relation, and when they say the relation, they just mean the graph, because it's a graph of a relation. So the domain, the x value of the relation is the interval, or is from -5 to -1, okay? I just printed it off with answers. So we said the domain are the x values. So I know I did this horizontal line, but within that horizontal line, I want to show you where it covers. Okay, in all of that x line, we're going to go from, as we said, x is -5 to, these graphs are way too small, x equals -1. Okay, so on all of x, the part we actually cover with the graph is between -5 and -1. So because that is an interval from -5 where it starts, the most negative place the graph exists, to -1, the most positive or the biggest the graph ever exists, okay? So, and it includes it, right? It does include a -5 and it does include a -1. So that's why we have the brackets from -5 to -1. If these were like open circles, right? Or if it just got right up to it but did not touch -5, that's when we would have these. But we see that it does touch -5 and -1, okay? So remember, domain is x. And then the next question they're going to ask you is, what is y? Okay, and it is, like I said, back to domain already. Like I said, it is confusing to me because I think if I have an arrow like this, why isn't the arrow going to go like this? And basically, you just have to trust that it goes in this way forever. Okay, don't overthink it. Just, they gave me that much. So if I were to continue this graph on my own, I would just keep going like that. Okay. However, if it doesn't have a pattern and it's just something more like this, then it's just going out and down, out and up forever. But if you can see a pattern that continues the entire graph, it goes that way forever. All right, so back onto range. Range is the pink one. So the range is where on y it's going to go. Okay, how far up and down. Okay, whereas the domain was how far left or right the graph went. The range is all the y values the graph will cover. So we decided that the x values it covers are between -5 and -1. The y values it's going to cover is it goes in this way forever. Okay? Even as I get to the bottom of my page, I still add an arrow. So those arrows mean it never stops, right? And so when something never stops, we write infinity. Infinity never gets a bracket, it always gets parentheses because you can't get to the end of infinity and include it. We're just saying infinity without having an end. So it's going up forever, it's going up into infinity, and then it's going down into negative infinity. Okay, so range is y, domain is x. Where is it on the x? It's between -5 and -1. Where is it on the y? It's everywhere on the y, right? Up and down. It's going to go way past 10 and it's going to go way past -10. It just goes forever. Okay, there's no really way for me to put that on the graph. It goes forever. It's not, right? It would not be a single value. I'll show you what a single value would look like on the y-axis. So here's a single value on the x-axis. Domain is 4. On the y-axis, or sorry, for the range, yeah, it does use the y-axis. For the range to have a single value, that means we'll say that's -1. So now my range is -1, a single value. It goes forever in both directions. The range of this is -1. The domain of this, right, you could say is parentheses, negative infinity, positive infinity. Sorry, last minute addition. And here the domain is 4. The range can be negative infinity to infinity. Good. So you're just deciding where is, if it's the domain, you're saying, what is the x value? What are all the x values? If it's range, what are the y values? What is every y value of that line? Okay, same down here, even though it's written terribly. So my range is all of my y values. Ooh, wrong color. Keeping it so clean, right? Range is all my y values. Domain is all of my x values. So on my x, it goes forever, but on y, it only exists at -1. All right, so the graph is or is not the graph of a function because of the vertical line test. All right, I'm going to rewrite the graph because it's already gotten so messy up there. For the vertical line test, it doesn't matter where the graph is, it just matters what the graph is doing. I know that's not as well as Pearson's did it, but here was what we were working with. And remember, a vertical line test means anywhere on the coordinate plane. So I'm going to take a vertical line. Here, it doesn't cross, right? Here, it doesn't cross anywhere. But here, it crosses many, many, many times, right? So we say the vertical line oh, it's confusing. I don't like this question. So is the graph of a function, right? So we know that according to the vertical line test, a vertical line be drawn so that it intersects the graph. I don't like the way they worded this question. Okay, would you say this is or is not a function? We know if the vertical line test, when you take the vertical line test, crosses more than once, right? It is not a function. So we have to start here. The graph is not the graph of a function, okay? Because the graph, you could say is, cannot, exactly once, right? but we know it's not a function. The graph is not the graph of a function. A vertical line, now you have to read them both at the same time. A vertical line be drawn so that it intersects the graph. So because when I draw a vertical line, it intersects the graph. When I do it, it intersects the graph more than once. Right? Not exactly one time and not 0 times, right? It could be 0 times, but that doesn't really address like the actual function. You can draw it over here, but if we're talking about only drawing it where there is a representation of the function, it's going to be more than once. So the graph is not the graph of a function. If I do draw a line, or when I do draw a vertical line, it intersects the graph more than once. So now I'm going to go back to number 2 because I feel like this is confusing, right? When a vertical line can be drawn so that it intersects the graph more than once, right? So the graph is not the graph of a function. I know it's not a function because which one of these is the most true about something that is not a function, right? If it's not a function, it's not more than once, and then come back up to can. Okay. Now on to 20. Find the domain and the range of the relation shown in the graph to the right. Use the vertical line test to determine whether the graph is a graph of a function. Okay, I paused it because I wanted to see what you were doing, and you got this part, which is I find confusing and difficult to teach. So I'm glad you got this part correct. All right, on to number 20. So it says find the domain and the range of the relation shown on the graph to the right. Remember, same thing, okay? Domain, all your x. The domain is your x, okay? That means, let's just do it right now, right? That means my domain is from here, graphs are way too small, to here. All right, let me count that already. So I assume this is 0, 0, 1, 2. So this is x equals 2 if I was going to make it a line, right? And that line is where the circle is the furthest to the right the circle gets is x equals 2, I think. And then from 0, 0, negative 1, 2, 3, 4, 5. X is negative 5. Okay, so if they're going to ask me the domain, I am going to look on the x-axis and I'm going to say the smallest number on the x-axis, the smallest, the most negative point that the graph touches is going to be negative 5, and the most positive the graph touches is going to be positive 2. Okay, so if I had to write that, I would say that this is not a single value. Remember, a single value would have to be only touching x in one place. Okay. Instead, it has an interval. Oh no, they said negative 6. Obviously negative 6. I think I just wrote negative 5. I think I said negative 6, but if I didn't, this graph is tiny and you know my pain, right? You've had to do way more of these than me. All right, so we counted from the origin, positive 2, negative 6. So it is between, and remember, if it touches negative 6, which it does right here, because we can name that point, I have no idea. Negative 6, too old to look at things so small. 1, 2, 3. Negative 3. Right? If that's my point. I have negative 6, negative 3. So I know it does include negative 6. And then it does include positive 2. Maybe that's positive 2. It's obviously negative 4, Kelly. Ugh. to -4. Good. So it goes from -6 to +2. So that would be my domain, because my domain is asking me, what are my x values? My x values are between -6 and +2, everything between -6 and +2, right? Because a line is just all points touching each other. So there's no point that's excluded unless you see a hollow circle that excludes that point. But we're going to say that it contains from and including -6 to and including +2 is my domain. Okay. So the domain, or the x values, are from -6 to 2 on the x. Okay. Now range, they ask the same thing. Range is how far up and down our graph goes. Okay. So again, it's outlined in purple. How high up does it go? Remember, this one went up forever, so we just said infinity, negative infinity. This one has boundaries, so the highest it goes is what looks like 0, right? Maybe this point 0, -2. So when y is 0 at its tallest, because range, we're talking about y. So the highest y value we get is 0. Y equals 0 at, right? 0, -2, we decided. Obviously, I wrote those backwards. Ignore me. And then I do that a lot when I'm focusing on y, I write y first. Mistake though. Okay, so at from the origin, -2, 0. And then down here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Here is -2, -8, right? So that's just plotting points. That has nothing to do with how we draw this, right? If we're deciding whether it includes all of that, we're just saying this is the point -2, 0. This is the point -2, -8. This is the point -6, -4. This is the point 2, -4. So my y's here are what is important. For these 2 points, my y's are what is important, 0 and -8. For these 2 points, my x's are what's important, this -6 and the +2. Okay, so the furthest it goes is from y equals 0 to y equals -8, right? And then our x's go from x equals -6 to x equals 2. You're just finding the widest point and saying, what are your x's from what to what? Find your longest point and saying, what are your y's from what to what? And obviously, here I started at the most negative and went to positive. Here I started at the most positive and went to negative. You should write it with the most negative first. So my range for the circle is between -8 on my y-axis to 0 on my y-axis. This is the highest it goes. This is the lowest it goes. And then number 30, you asked about? You didn't ask, I just looked at your My Math Lab. All right, given the function g of x equals 3x squared plus 9, find the indicated values. So g of x equals 3x squared plus 9. What they're saying is this x is this x. So instead of x, for g of, this is called g of x, okay? G of x. For g of x, we have 3x squared plus 9. That's as simple as we can make it. Now this is g of negative 10. G of negative 10 means take that x, turn it into a negative 10. 3 negative 10 squared plus 9. Now put it into your calculator. Don't forget the parentheses because you have to take that negative 10 and square it. Negative 10 squared is 100, but negative 10 without the parentheses squared is negative 100, okay? And if you have a calculator where you're going to put all of it in at once, if you just did 3 times negative 10 squared plus 9, you're going to get a different answer than if you put in 3 parentheses negative 10 squared. Oh no! I'm making this video so long and it shouldn't be. I'm sorry. Oh. 3 times negative 10 squared plus 9. 309. Good. I just replaced the negative 10 with, replace the x with the negative 10. So 3, or we could do it by hand. 3 negative 10 squared is 100. So 3 times 100 plus 9. 3 times 100 is 300 plus 9 is 309. Good. Now g of negative 1, same equation. So we had g of x is 3x squared plus 9. Keep your parentheses just because if you make a mistake, it can be frustrating. So 3 times negative 1 squared plus 9. 3 times negative 1 squared is just 1 plus 9. 3 times 1 is 3 plus 9 is 12. Okay, last one. G of 5/3 looks like this. 3 times 5/3 squared plus 9. Good. Now, even if you don't have a calculator that's easy for you to put that into, you can still solve because we know how to take 5 and square it, and we know how to take 3 and square it, okay? So 3 times, and I'm just going to square. So this can become 3 times 5 squared divided by 3 squared plus 9, okay? So then that's 3 times 5 times 5 is, and also do this in your calculator if you don't want to do it this way. 5 times 5 is 25, 3 times 3 is 9, good, plus 9. Now if I want to multiply the 3 times the 25 divided by 9, I just turn the 3 into a fraction. So 3 over 1, because 3 divided by 1 is still 3. Anything, if you want to turn anything into a fraction ever, you just divide it by 1. It maintains its original value, but now you can use it as a fraction. 3 divided by 1 times 25 divided by 9 is, and then we just multiply straight across. 3 times 25 is 100 and, nope, it's just 75, right? And then 1 times 9 is 9, and then we're going to add 9 to that. 75 and 9. I think you can divide them by both by 3, right? Okay, if I take 75 and I divide it by 3, I get 25. If I take 9 and I divide it by 3, I get 3. So 75 ninths can be simplified to 25 thirds plus 9. Okay. Now, if you don't have a calculator, you can just do this. And it's also, yeah, because they're going to ask you for a fraction. So if you don't have if you have a calculator that can do it, just do it with your calculator. If not, what we do is we take 9 and we make it into a number over 3, okay? Because when you're adding or subtracting fractions, what you need to do is have the same denominator. So right now I have 25. I'm going to put it down here. What I have is 25 over 3 plus 9, right? And I said if I want to change it to a fraction, I just put 1 over it. Sorry, put it over 1, the opposite of what I just said. But I need 3 and the 1 to be the same. So if I need them to be the same, I need to find a common multiple. So like the lowest common multiple that would turn them into the same number. So it's a 1, so that's a pretty easy choice. I can take 1 and I can multiply it by 3, right? If I multiply 1 by 3, then they'll both have 3 as their base. Anything I do to the bottom of my fraction, I have to do to the top of my fraction. Good. So now I'm going to have 25 thirds plus, I'm going to change this to something over 3. So 9 times 3 is 27. And then 1 times 3 is 3. And now, since they both have a base of 3, I can just add 25 plus 27 is 52. My answer is 52 thirds.